Okay, in today's session we're going to talk about polynomial basics. So we're going to introduce polynomials. So we're going to start with just some general vocabulary. First is defining what it means to be a term. Okay, so let's say a term is a collection of constants, products, and variables raised to exponents. Collection of constants, products, and variables raised to exponents, and they are separated by pluses and minuses. So separated by plus and minus signs. So let's take a look. Okay, so we have negative 3x to the third plus 4x squared minus x plus 2. Okay, we would consider this an expression. Okay, generally speaking, we would consider the whole thing an expression. And it's not an equation because we said equations are defined by having an equal sign in them. So it's not an equation and it's not an inequality, because inequalities have the greater than or less than sign in them. So this would be considered an expression. Now, what we're wanting to do is see what makes up this expression. And based on our definition for term, we see that a term is a collection of constants. Well, here's a constant. Products. Well, product means two things being multiplied side by side, two things listed next to each other. So in this case, the negative 3 and the x, and in this case, the 4 and the x. Alright, and variables raised to exponents. Variables raised to exponent. That variable is raised to an exponent. That variable is raised to an exponent. And you could argue that this negative x is the same as saying negative x raised to the first. Okay, so the fact that you see the x is like saying it's to the first degree. Okay, exponent of 1. Alright, so what we're looking here is a collection of terms. So in this case, 4 terms. The terms would be negative 3x to the third, 4x squared, negative x, and 2. Okay, so when we list out the terms, we don't list it as an expression, we just list them as individual terms. So the first term was a negative 3x to the third, and notice we kept the negative sign attached with it, or the minus sign, however you want to look at it. The positive 4x squared, the negative 1x, and the constant of positive 2. Those would be considered the terms. Okay, let's look at another expression. Let's say we have 5x squared y plus 3xy minus xy squared plus 7. Okay, and if I were to ask you how many terms do you see, well, you're looking to see how many items are separated by plus and minus signs. Okay, so here's a plus sign, here's a minus sign, here's a plus sign. So we have 1, 2, 3, 4 items separated by pluses and minuses, just like we did here. You had this, that, in that they were separated by pluses and minuses. So our terms in this case would be first we would write the 5x squared y, comma, then we write 3xy, comma, then we write negative xy squared, comma, and then we write our positive 7. Okay, so again, these are examples of terms. One term, 2, 3, 4. Now, when we're looking at terms, it's important that we understand what a term is made of. And going back to our first example, if we look at this negative 3 that's in front of the x, this positive 4, in this case that negative is like saying a negative 1, and this positive 2, these are all considered coefficients. Okay, coefficients. So coefficients are, I guess for lack of a technical way to put it, the big numbers that are in front of the variable. The big numbers in front of the variable. Okay, so what the variable is being multiplied by. So the big numbers in front of the variable. Alright, and that includes constants. Okay, that includes constants. Alright, so if we're looking at our second example, this example over here, then we would see that our coefficients would be positive 5, positive 3, negative 1, and 7. 5, 3, negative 1, 7. Again, those would be our coefficients. Okay, so just want to make sure that we have a good understanding of terms, how to identify terms, and that terms are separated by plus and minus signs. Terms are separated by plus and minus signs, and terms are made up of the variable and their exponent, but also made up of coefficients, which are the big numbers in front of the variable. And if you see a variable without a number in front of it, then it's understood to be 1. Okay, so anytime you see a variable like that and you need to know its coefficient, the coefficient would be considered 1, because y is the same as saying 1y. X is the same as saying 1x. Alright, moving on. So now we'll talk about what it means to be a polynomial now that we understand terms of an expression. So a polynomial is basically a special kind of algebraic polynomial is a special kind of algebraic expression alright, where the terms, alright, and we just talked about what terms are, where the terms are in the form of ax to the n, ax to the n. Alright, and it's important that we note that in this form a must be a real number and n must be a whole number. Okay, so we're saying Polynomial. Polynomial is a special algebraic expression where the terms are in the form of ax to the n, where a would be considered a real number, or a has to be a real number, excuse me, and n has to be a whole number. Okay? And basically, to help you understand what we're talking about when we're saying a and n, a would be the coefficient. Alright, so the coefficient would have to be a real number, and n is nothing but the exponent. Okay, so the exponent would have to be a whole number. So the a, which is the coefficient, must be a real number, and the n, which is the exponent, must be a whole number. Okay, and in order for the expression to be considered a polynomial. So let's take a look. 3x to the fourth minus x to the third plus 6x squared minus 11x plus 13. Alright, so what they're saying is this is our a, that's our n. This right here is our a, that's our n. That's our a, that's our n. A, and in this case our n would be considered a 1. Alright, and this would be our a, and in this case our n would be like saying x to the 0. So our n would be the 0 for a constant. Okay, our n would be 0 for a constant. So if we're going to look at this is an expression. Alright, we already know it's an expression. The whole thing is an expression, we know that. But a polynomial is a special type of algebraic expression. So we want to see if this expression is actually a polynomial. So in order for us to make that determination, we have to make sure that, again, a is each coefficient is a real number, and all of the n's, all of the exponents, are whole numbers. So if I look at all my a's, in this case positive 3 is my a, in this case negative 1 is my a, in this case positive 6, in this case negative 11, in this case 13. Those are my a's. All of those a's are whole real numbers. So that checks out. We're good. All of the a's are real numbers. So then we look at our n's to see if they're all whole numbers. Well, remember we talked about how whole numbers start at 0 and go to positive infinity, but in whole units, no fractions, no decimals, no radicals. Okay, so 0, 1, 2, 3, 4, 5, 6, 7, all the way up to positive infinity would be how we would define whole numbers. So if we look, this 4, this 3, this 2, this 1, which we don't write the 1, but it's understood to be there, and this 0, which again you would not see, but it's understood to be there for a constant, those are all considered to be whole numbers. So it checks out. So in this case we are dealing with a polynomial. So this would be considered a polynomial. Let's look at another. Let's say we have 3x to the third minus 1/2 x squared plus 5. Okay, we want to ask, is this a polynomial? We know it's an expression, but is it a polynomial? Well, once again, we have to look at all of the a's, which are the coefficients. We have to check all the a's, which are the coefficients. So our a is this 3, our a is at negative 1/2, and our a is at 5. Okay, and again, these are our coefficients. Our A represents coefficients, and we have to ask ourselves, are these all real numbers? And the answer is yes. 3 is a real number. -1/2 is a real number. If you're trying to understand what real numbers are, tell yourself, if it can be written on a number line, then it's a real number. So real numbers can be whole numbers, integers, which account for negative numbers. Real numbers can be fractions. Real numbers can be decimals. Real numbers can be radicals. All right. So if it fits any of those categories, if it can be written on a number line somewhere, then it is a real number. Okay. So all of our coefficients, all of our A's check out. All right. These are our A's, and they all check out. They're all real numbers. So it meets that criteria. Now we look at our exponents, our n's. Okay, and once again, because this is a constant, it's the same as if we said, instead of just saying 5, we could also look at this as being 5x to the 0, saying there are no x's, 0x. There aren't any x's. So this 5, which was a constant, could also be written as 5x to the 0, and in that case, your exponent is 0. So when you analyze all of the n's, you see that they are indeed whole numbers. So all of the exponents are whole numbers, so that checks out. So this would be considered a polynomial. Okay, now let's say we have 3x to the third plus 2x to the 1/2. Oops, that's supposed to be an x. Plus 2x to the 1/2 plus 5. Okay, when we look at our A's, 3, 2, 5, those are all real numbers. Those check out, so we're good there. Okay, all of our A's check out, so that would be good. So then we have to check our n's, our exponents. So we look at our exponents, and again, this would be a 0. It'd be like saying x to the 0. So when we look at all of our exponents, we notice right here 1/2 is not a whole number, and our exponents have to be whole numbers. Our exponents have to be whole numbers, and this 1/2 is not considered a whole number. So because of that 1/2 in this expression, this is not a polynomial. Okay, would not be an example of a polynomial. Let's say I have 3.5 x to the 5th plus 0.7 x to the 3rd minus x to the -1 plus 2. Okay, in this case, alright, once again we check our A's, our coefficients. So you got the 3.5, you have the 0.7. Remember that minus in front is like saying a -1, and you have your positive 2. So all of our coefficients are good. They're all real numbers. Okay, even though they're decimals, that still is a real number. Again, a decimal can be written on a number line, so it is a real number. So now we look at our exponents, and remember, this is like saying x to the 0. So when we look at our exponents, okay, they have to be whole numbers. Well, we said whole numbers start at 0 and go to positive infinity. Whole numbers do not take into account negative numbers. So the fact that we have a negative exponent tells me that we do not have a whole number. It would be an integer but not a whole number. So this is not a polynomial. Not a polynomial. Alright, so hopefully you're getting the idea here as to how to determine what is and what is not a polynomial. Okay? Now, once we understand what is a polynomial, then we can talk about that there are special kinds of polynomials. Alright. So if I had 3x to the third, if you're asked how many terms would that be, this is considered just one term. Alright, because remember, terms are separated by pluses and minuses. So if I put a plus sign and something else up here, then now I'd have two terms. But because we're just talking about 3x to the third, then this would be considered just one term. And because it's only one term, we call it monomial. Mono meaning one. Monomial, one term. Now we have two terms. One term, two terms. Two terms. Binomial. Bi meaning two, like a bicycle, two tires. Okay, two wheels. Alright. Oops. Now we're looking at three terms, trinomial. Tri meaning three, tricycle, three tires or three wheels. Okay. And then last but not least, one, two, three, four terms now. And we think four, we think quad, right? Quadrinomial. But no, it's not. It's not quad. That's what most people want to think. But it becomes poly. Oops. Didn't mean to erase all of that. I mean to underline all of that. Poly. Poly just meaning many. Okay? So understand, after the first three, one term is a monomial, two terms a binomial, three terms trinomial, everything else, 4 terms, 5 terms, 6 term expression, 7 term polynomial, alright? Everything else is called a polynomial after 3 term polynomial, okay? 4 terms or more is all called polynomial, alright? Now, let's talk about degree. Degree is described as basically the greatest sum of exponents. Greatest sum of exponents for any one term. For any one term in a polynomial. Alright? Degree. But this in particular we're talking about not the degree of a term, but the degree of a polynomial. Alright, degree of a polynomial. Degree of a polynomial is determined by the greatest sum of exponents for any one term in that polynomial. Okay, so let's talk about degree. Let's say we have this polynomial that we stopped with over here, 3x to the third plus 2x squared plus x plus 5. Alright, if we were asked to find the degree of each term, okay, the degree of each term, degree, you know, degree sign like for Fahrenheit or degrees Celsius, the little open circle. The degree for each term, because there's only one variable in this polynomial, the degree would simply be the exponent for each term. So because x is raised to the third power, that term would be considered third degree. Here x is raised to the second power, so it would be second degree. Excuse me, didn't mean to circle that. This x, when you just have an x by itself, it's like saying x to the first. Okay, so first degree, and this 5, which is a constant, would be the same as saying 5x to the 0, so that's 0 degree. Alright, so this would be considered the degree of each term. So the first term's degree is third degree, second term's degree is second degree, third term's degree is first degree, and the last term's degree is 0. Now, the degree of the polynomial, the degree of the whole thing, the degree of the whole thing is determined by whatever the highest number is in our list. So we look at our list of degrees for the terms, and whatever the highest degree we come up with, that's the degree for the whole polynomial. So because third is the highest out of these we have listed, the degree for the entire polynomial would be considered third degree. Alright, so let's look at another one. Let's say we have something like 4x y squared z minus x to the fourth y plus 8 y to the seventh minus z to the third plus 5. So let's say we have this polynomial here. So we have what, 1, 2, 3, 4, 5 terms. So it's a 5-term polynomial. Alright, 5-term polynomial. And we want to know the degree of each term. The degree of each term. Alright, well, when we look at the first term, we have multiple variables here. So in the last problem we only had one variable, so the degree for that term was just whatever the exponent was for that term, right? But now because we have multiple variables, we add up all the exponents for those variables. So this x right here is like saying x to the 1. You have y squared, or y to the second, and the z is like saying z to the 1. So when you add those all up, the degree for that term would be 1 plus 2 is 3 plus 1 is 4, so fourth degree. Now we move on to the next. We have an x to the fourth, and we have this y, and that y is like saying y to the 1. So we would add these up, 4 and 1, so that would be like saying that term is raised to the 5th degree. Here you only have a y, and that y is raised to the 7th, so this would be 7th degree. Here you have a z, and that z is raised to the 3rd. It's the only variable you have, so that's easy. It's just 3rd degree. And here you have a constant, which is like saying that constant times whatever variable you want to say to the 0, or just look at it as saying you don't have an exponent, so the equivalent of saying, oh, you don't have a variable, excuse me, so the equivalent of saying 0 degree. Okay, so a constant is always going to be a 0 degree. Now that's the degree of the term, but we need to know the degree of the whole thing, the degree of the entire polynomial. So for the whole thing, what's the degree? And once again, the degree for the entire polynomial is determined by the highest degree in our list of degrees for each term. So if we look at all the degrees we have listed for each term, the highest one in the group is 7th. So this polynomial would be considered a 7th degree polynomial. Alright, so that's degree. Now, we use degree to help us write polynomials in what we call decreasing or descending order. Alright, decreasing or descending order. Some people call it standard form, but we use degree excuse me, to write a polynomial in decreasing or descending order. Okay, so what we do is we take the polynomial. So let's say this polynomial we were given here, alright, and we listed the degree of each term. Now, to write this polynomial in standard form, or to write it in decreasing or descending order, we would arrange the terms in the polynomial based on the highest degree counting down to the lowest degree. Okay, so because we said the highest degree was 7th, then we would write that term that's associated with the 7th degree, which is the positive 8y to the 7th. We would write it first. Okay, then we'd count down. Well, after the 7th, the next highest is the 5th, so we'd write that term next. So it's minus x to the 4th y, so we write minus x to the 4th y. Okay, so that's the 7th, then the 5th, counting down, next highest would be 4th. So this is a positive 4x y squared z, so I say plus 4x y squared z. Then after 4th is 3rd, which is minus z to the 3rd, so minus z to the 3rd, and the lowest degree was the constant, which was a plus 5, so we write our plus 5. So what we've done is taking this polynomial and written it in decreasing or descending order, or again what some people call standard form. Alright, let's look at another one. Let's say we had negative x plus 8x to the 3rd minus 5 plus 9x to the 5th plus x to the 4th. Okay, so when we look at this polynomial here, this is an easier one because there's only one variable in the terms. So basically we can determine the degree of each term by just the exponent of the variable in that term. So if we look, the highest degree would be 9x to the 5th because the highest exponent is 5. Alright, so 9x to the 5th would be the highest degree term in this polynomial. So if we're going to write this polynomial in decreasing or descending order, we would turn around and we'd write the 9x to the 5th first. Alright, now counting down, after the 5th, next highest would be 4th, so we say plus x to the 4th right here, plus x to the 4th. Okay, after x to the 4th is x to the 3rd, third degree, so plus 8x to the 3rd. Alright, and after x to the 3rd, there aren't any x squares, so then I just look for x's, which is like saying x to the 1st. So I have a negative 1x to the 1st, or a negative 1x. So I'd write that because that's first degree. And then the only thing that's smaller than the first degree would be a constant, which is a degree of 0. And here we have our constant of negative 5 or minus 5, which is a degree of 0. So we write that minus 5. Okay? So this represents the polynomial in decreasing or descending order, or what we would call standard form for a polynomial. Alright? So at this time we will conclude the session on polynomial basics, and we will follow up with further sessions on polynomial operations. Thank you.